All right, welcome back. So we just looked at the amplitude of a sine or cosine function, and so we can see how the variable in front will cause that to be either a vertical stretch or a vertical shrink. So now we're going to take a look at the next variable, which was b, and so we have a sine of bx versus a uh, sine of x. So basically, what is that b doing to the function? So we're going to compare just a couple of specific examples. So we have our regular sine function, and then we have sine of 2x. So remember, if we have 1 and negative 1, pi over 2, pi, 3 pi over 2, and 2 pi. That should be a standard thing you should always start to do when you're drawing these by hand. Just get those key locations identified so that way you can get a decent sketch. So we know that sine starts at 0, goes up to 1, back down to 0, down to negative 1, and back up to 0. So there's our sine function. All right, so now if we want to start looking at the sine of 2x, let's again start looking at our 5 key points. So if we plugged in 0, then we're going to get 0. So sine of 0 is still 0. So we're still starting at the origin. So now if we plug in pi over 2 for x, if we plug in pi over 2, we can see that's going to double it. So we're going to end up with pi. And what's the sine of pi? Well, the sine of pi is 0. So we actually are at 0 here. When we plug in pi, you can see that we're going to get 2 pi as our angle. So sine of 2 pi is still 0. And you can kind of see that at all of our key points, we're just going to get 0, which doesn't really help us much for graphing. So we're going to have to look at some values in between. So let's maybe take a look at pi over 4. So if we take a look at pi over 4 for an angle, we plug that in. If we double pi over 4, that's going to reduce down to pi over 2. And lo and behold, sine of pi over 2 is 1. So at pi over 4, we actually get a max value of 1. And so if we did the same thing over here, and we looked at halfway between, that's going to be 3 pi over 4. So we get the same situation. So when we multiply it by 2, it's going to reduce down to 3 pi over 2, and the sine of 3 pi over 2 is negative 1. So now you can kind of see we do have that sinusoidal curve in there. So if we just kind of sketch that in, and lo and behold, there's our sine function. So basically, now we can see it's being squished. In this case, when we have sine of 2x, that's going to give us a period of pi. So we go through one complete cycle in pi units. So how could we possibly stretch that out? Well, let's take a look at the next page here. Well, so we have now a definition for our period and how we can describe it and define it. So if we let b be a positive real number, the period of y equals a sine of bx and y equals a cosine of bx is given by period equals 2 pi over b. So we can see that if we plugged in 2 for b, that's going to cancel the 2's out. You're left with pi for the period. So that is our formula. So when we have b equals 2, we get a horizontal shrink. How would we get a horizontal stretch? So we're going to need values, you probably guessed this already, but we're going to need values smaller than 1. So in this case, if we got y equals the cosine of x over 2, one of the things we could do just to see that value of b a little clearly is just to rewrite this. So if we set this equal to the cosine of 1/2 x, now we can see the value of b is 1/2. So a couple of things that we should notice in here is that our amplitude should be equal to 1. The value in front of our cosine function is 1. And now we also know our period. So our period should be equal to 2 pi over b. Now b in this case is 1/2. So if we substitute 1/2 in here and simplify this, we're going to get 4 pi. So 4 pi is now the period. So when we write out our labels for our blank graph, we want to be a little bit careful and keep this period in mind. So I'll show you a little trick for that. So the first things first, so let's worry about our amplitude. We know is 1, so we can go 1 and minus 1. But our period is 4 pi. So how do we get all these dashes and have it mathematically right? Here's the trick. Always start with your fourth dash as your period. So in this case, we would say this is 4 pi. Now just keep cutting it in half. If we cut it in half, we should know the middle dash should be 2 pi. If we cut that in half, then this is going to be 1 pi. Now, we haven't been labeling on this side over here, but we could very easily just make it the negative of this first dash. And so the last and not least is the third dash. And the easiest way to get the third dash is to triple the first one. So if we multiply this by 3, we get our third dash. And that's the easiest way to get these values. So we're going to see this repeated as we do other problems. So if you don't quite got it yet, don't worry, we're going to do it more throughout. So now we have our blank graph. Now we're just going to be careful, make sure we know which one we're graphing. We're graphing cosine, so we know that's our U-shaped graph. So we should start up at our high point. We want to go down again, go up, and go up. And then just make it curvy, and you'll be done. And there we have it. So there's, again, it's just one cycle. Now you want to be careful about your homework. Sometimes they want 2 full cycles, so you might have to draw it twice. And getting those other labels, really you could use the same trick and just, multiply the first dash times 2, times 3, times 4, times 5, times 6, times 7, as much as you need to get 2 complete cycles. And just make sure you reduce those down to lowest terms to make it look nice. All right. So we went through quite a bit there, so let's stop for that, and then we're going to get into translations last but not least. So now we're going to start shifting those babies around. So we'll see that in the next video. Stay tuned.